All right, so I'm recording. Here we go. Okay. Also, before I forget, I did post some new practice questions from the textbook. You can do. Again, they're not to hand in. It's just for practice only. Okay? But if you ever want to go over one with me or a few or whatever, if you want to work with them, if you want to meet me in office hours and ask me to help you with some, that's fine also. I've done that with people in the past. So, okay. So here we have tangent of theta is a third, okay? We do know that theta is acute, right? Meaning it's between 0 and 90 degrees, okay? We want to figure out what the other trig functions at theta are. We're not going to figure out theta. So, as before, we want to form a right triangle, okay? We want theta to be one of the angles besides the 90-degree one. Basically, we want to form a right triangle so that this is true. That's what we want to happen, okay? Okay, so I'm going to put theta down here, right? Now remember, tangent of theta is opposite over adjacent, right? Opposite over adjacent. Okay, so the opposite side, since theta is down here, the opposite side is here. The adjacent side is here. So tangent of theta is a third. We have opposite side is length 1. The adjacent side is length 3, right? So for this right triangle, this is true. But again, we want to get all the other trig functions, right? So we need to know what the hypotenuse is, the remaining side. So I called that x. What do? We use Pythagorean's theorem, right? Namely, what's going to happen is we're going to have 3 squared, right? A squared plus b squared is c squared. So we have a squared plus b squared is c squared. So 3 squared plus 1 squared is x squared. Interchanging both sides, you get x squared equals 3 squared plus 1 squared. Okay, so we have to figure out what x is. Well, 3 squared is 9. 1 squared is 1, right? So x squared is equal to 10, right? X squared is 10. We don't want x squared, we want x. So x is square root of 10, right? X squared is 10. X then is square root of 10. So that's what we get. Good. So that's what the hypotenuse is. So our right triangle is going to look like this, as you can see. Okay, but now we can get all the trig functions, right? I mean, we know tangent already. So, okay, so what happens then? Well, sine of theta, that's equal to opposite divided by hypotenuse. Opposite, hypotenuse. Opposite, hypotenuse. So we get 1 over radical 10. Cosecant is 1 over sine. 1 over means you flip it. So we have to flip this, invert this. We get radical 10 over 1, which is radical 10. Okay? So that's what we get here. Okay? Now, for cosine of theta, that's adjacent over hypotenuse. Adjacent over hypotenuse. So we have 3 over radical 10 for cosine theta. Now for secant of theta, right? That's 1 over cosine. 1 over, invert it. So this becomes radical 10 over 3. And finally, we know tangent's a third. Cotangent is 1 over tangent, which means you you do 1 over tangent, which means you flip tangent. So you get 3 over 1, which is just 3. So that's what we get here. All right, any questions on that? Okay, so if you looked so far, we said sine of theta, cosine of theta, but we never had a specific angle for theta. We never had that. We never said like theta was 40 degrees, or, we never found tangent of 60 degrees, stuff like that. Well, you can actually do that. You just need to work with specific angles. Excuse me, specific triangles. That's what you have to work with. Namely, what we're going to do now is we're going to consider an isosceles right triangle. Okay, an isosceles right triangle. Okay, so an isosceles triangle, remember, that means 2 of the sides are equal. And it's a right triangle, so one of the angles must be 90 degrees. Although if you think about it for a minute, it's really not hard to see, that the 90-degree angle has to be between the 2 equal sides. Mostly because since the 2 sides are equal, the angles opposite it have to also be equal. Okay? And they both can't be 90 degrees. That's impossible. So that forces this angle to be 90 degrees. So that's what happens here. Now, the 2 sides of equal length, we could actually let them be any length we want, but for convenience, we chose 1. It actually turns out since we're dealing with trig functions, these 2 side lengths could be these 2 sides could have any length we want. But for fun, for convenience, we'll make them 1. And this is the hypotenuse then, because this is opposite the 90-degree angle. Now, just to make this more consistent, here we rotate. Here we can rewrite this triangle, or redraw it, that is. So it's like this. This side, remember, this angle up here is also 45 degrees. This one is also, okay? So what do? Well, from here, we can calculate C using Pythagorean's theorem, right? We have a squared plus b squared is c squared. So in this case, a and b are both equal to 1. So a squared, a and b are both equal to 1. So c squared is 1 squared plus 1 squared, which is c squared. So c squared is 1 squared plus 1 squared, which of course is 1 plus 1, which is 2. So c squared is 2. Therefore, c is the square root of 2. So that's what we get here. Okay, that's what we get here. Good. Okay, that's good. So that's what we get here. The c is the square root of 2. And this is just saying also that, the 2 angles that are equal must be 45 degrees, that stuff like I said before. But once we know what c is, we can actually get the trig functions of 45 degrees, right? Because now our triangle becomes this. And I forgot to say this. This triangle you can actually obtain from a square where each side length is 1. Or really any side length, or really any length you want, actually. But anyway, we have this triangle. The angle is 45 degrees, okay? So because of that, we can get sine and cosine of 45 degrees, and tangent as well. Namely, wait, actually I made a mistake. There we go. Sine of 45 degrees, what is that going to be? Well, that's opposite over hypotenuse, which is 1 over the square root of 2, as so. Now, this is not wrong to leave it like this, 1 over the square root of 2. What people do, though, is they rationalize the denominator. And again, that just means they rewrite this so that the denominator has no square roots in it. Well, to get from here to here, you multiply top and bottom by the square root of 2. I mean, I did do that for the other class because someone asked the question. So someone asked about it, that is. But again, I think we've done this before. You could just multiply top and bottom by the square root of 2. Doing so, you get square root of 2 divided by 2. Cosine of 45 degrees turns out to also be, well, it's adjacent over hypotenuse, which is 1 over square root of 2. 1 over square root of 2. Okay. Now, tangent of 45 degrees, I use the fact that tangent is sine over cosine. And sine and cosine are actually equal, so tangent's going to be 1. But you could use the triangle directly if you want, because tangent is opposite over adjacent. Opposite over adjacent, so tangent of 45 degrees is opposite over adjacent, which is 1 over 1, which is 1. And what I also did was I converted 45 degrees to radians. And remember, let me just fix something there. I forgot something. This should be 45 degrees. See if I can draw that symbol. Close enough. Times pi over 180 degrees. Because when you multiply, the degrees cancel, the degree unit that is. You get 45 times pi over 180, which is pi over 4. So that's what we get here. Okay. And I just wrote down sine, cosine, and tangent as well. So, and I wrote them also in radians. So, because again, if you go on into higher level math classes like calculus and above, you're really just going to work in radians. So, something that's good to know. Are there any questions on this? Yeah.
Can you go over like where the recall part is? Like I don't really understand where the numbers and where the pi is coming in from.
Oh, this part here?
Yeah.
So basically what I did was I converted 45 degrees to radians. And to do that, you have to multiply by pi over 180 degrees. That's just how you convert from degrees to radians.
Okay.
So when we multiply, right, these degrees cancel, the unit does, and we're left with 45 times pi over 180. But we can actually reduce that because 180 turns out to be 45 times 4, so the 45's cancel.
Okay.
Does that help?
Yeah, that does.
Okay, good. Good question. Very good question.